Good morning, Algebra 1 students, and welcome back to your Semester 2 final review. We are on to problem 43, which comes from lesson 7.6. They are asking us which of the following are the x-intercepts for y equals the quantity x plus 2 squared minus 16. So to get an indication of what we're trying to do here, I'm just going to first sketch you a nice cute little graph of the situation. We know that this equation is in vertex form. That's what topic 7 was all about. So I know that my vertex here is going to be negative 2 comma negative 16. So negative 2 comma negative 16. And because the a value is 1, my graph opens up. Okay. That means that there are going to be two x-intercepts in this case. We can see these two right about here. And we don't know anything else about that. My graph is not very well drawn, but I do know that wherever these x-intercepts are, right, one of them is smaller than negative 2, and one is greater than negative 2. So I'm pretty sure that eliminates C and B right away because they have negative 2. We have x-intercepts here, okay, and we know to get along the x-axis, it's going to be some number, comma 0. And then over here, it's going to be some other number, comma 0. So by looking at those points, can we see that the y values have to be 0? That means then, to find our x-intercept, we need to replace the y in our equation with 0 and keep everything else as is. Now our entire task is to isolate x. And when we are solving for x and there's just a single x in the equation like there is here, that means we're going to be following SADMAP. To follow SADMAP, and I'm actually going to put the invisible 1 out front here just because sometimes problems are a little more complicated than this, and I think it's worth showing what could happen on your actual final. Let's identify everything that's attached to x. There is, of course, a 16 that is subtracting. There is a 1 that is multiplying. There is an exponent of a 2. And there is this 2 that is in parentheses. So we need to start from the top and work our way down. The first thing we undo is the subtraction by, of course, addition. And we need to do that to both sides. So that's going to give me 16 equals 1 times x plus 2 squared. And now the reason that I put the 1 in here, the reason I made it more complicated is because many of my students want to skip straight to this exponent and they go, oh, I know to undo an exponent we do a square root. And they're right, but they neglect the next part of SADMAP, which is the multiplication and division. The next thing we would have to do here is undo that 1 by dividing both sides. So we have to do division ahead of the square root. Don't forget that. It's really going to throw you off if you don't. So the 1's cancel. 16 divided by 1 is, of course, just 16. Now again, we didn't need to do that step, but it's worth showing you what you would do if there was a number multiplying or dividing by both sides. Now we can undo the exponent, and we discussed earlier that to undo a square, we introduce a square root. Okay. Square roots cancel and leaves us with x plus 2. Now on the left side, you have really 3 options here. Option 1 is you can substitute square root of 16 into your calculator, and you might get a decimal, you might not. Option 2 is you can actually break down the square root of 16. And option 3, you can just search your memory and see if 16 has a nice square root. Now I am not going to break down 16, and the reason why is because we generally only break down 16 if when you type this into your calculator you get some sort of irrational gross decimal. And so we would break it down if the answers up here had square roots that were also broken down, or just square roots in general. But there aren't any square roots up there. And if there aren't square roots in the answers, that means that the square root of 16 probably has a nice square root. And we should know what that square root is. The square root of 16, of course, is 4, because 4 times 4 is 16. Then, whenever we write in a square root, we also need to remember a plus minus, because not only does 4 times 4 equal 16, negative 4 times negative 4 also equals 16. So we need to continue with this plus minus. From here, we want to isolate x by subtracting off the 2 from each side. And remember, this part gets a little bit weird because technically we can't just subtract 2 from 4 because that's not 4. That is both 4 and negative 4, and subtracting 2 from two different numbers will give you two different answers. So what we do instead is we just leave the negative 2, we leave the plus minus 4 and say, ha, there's our answer. Unfortunately, they did not give us the answer like that up above, so what we're going to do is just make two different equations. We're going to say x is equal to negative 2 plus 4, and x is equal to negative 2 minus 4. Negative 2 plus 4 is like 4 minus 2, that's 2. Negative 2 minus 4, negative 6. And so what that tells us then is that our x-intercepts will be 2, 0, and negative 6, 0, which hopefully is an answer somewhere on here, and it is. It looks like it's an answer of A. Now, if you wanted a second way to do this, or a way to check your work, with a calculator it's pretty easy. You can just go ahead and say, oh, I think it's A, I think one of the answers is negative 6. You go, okay. Well, then you take your equation and you replace the x with negative 6. Right? We know the x is negative 6. Now, this point also tells us when the x is negative 6, the y better be 0. So if we look over here, if we do all the math here, what should the answer be? It should be 0. And in fact, if you do the math, and you can just type all that into your calculator if you want, or you could just follow PEMDAS here. That's what I'm doing. 16 minus 16, we do get 0. So what that tells me is that negative 6 is certainly a good answer. Then you would also try 2 and make sure you get 0, and you will get 0 as well. That's the only answer choice where both x values will give you 0. Hopefully this was a nice reminder of how to solve for the x-intercepts of an equation in vertex form. It's just SADMAP. Don't forget your square root has a plus minus as an answer. Hopefully you're still finding success on that final review and you're getting closer to being ready for your final exam.